Welcome to Lesson 4 on the topic of elasticity. Elasticity is one of those concepts that we're going to use a lot throughout the semester, so getting to understand it now is going to pay dividends throughout. So here we go. I'm going to give two examples to kind of get us started here on the concept. First comes from when I was a kid. I had a dog named Max when I was little. I really loved that dog. One day the dog got a hold of the turkey carcass, the leftover turkey that came from Thanksgiving dinner. Had to go to the vet hospital that night with food poisoning. My mom took him, and when she came back without the dog. And my brother and sister and my dad and I said, "What's going on?" She said, "Well, he's got to stay there overnight. He's got to have some procedure. Probably be okay, but they got to do some work on him." And my dad, the frugal one, says, "Well, what are we talking about here in terms of expense?" And she says, "Well, I think that we're looking at $5,000 or so." And I still remember his response vividly. He said, "Well, can't we just get a new dog?" So of course we all thought he was horrible, and we voted him down, and we ended up paying the $5,000 and keeping the dog, as probably many pet owners would do. So that's an example of that shows something about the elasticity concept of demand. There's some goods for which people are not that sensitive to price. They're willing to pay because of the nature of the good. A high price or the price changes don't affect their demand for that good very much. Whereas there's some other goods where price change might really affect your behavior and whether you buy that good or not. For instance, you guys go out to lunch a lot of seniors probably on 86th Street. There's a lot of options for you out there, and a change in price at one store might send you to another store very quickly because there's a lot of substitutes for that good. The demand for these two goods, pet care and restaurants on 86th Street, will look quite a bit different because of that sensitivity, and there will be a lot of effects of that on both consumer and producer behavior. So we're going to look at how this concept works, how we measure it through this lesson. So first I've got two numerical examples that just illustrate the stories I was just telling. The one on the left here, we're saying that what if the price of this good here, shown in this table, goes up from $5,000 to $6,000. That's a 20% increase in price from 5,000 to 6,000. And let's say it's this emergency pet care example. And let's say that as a result of that 20% increase in price, the quantity of this good of emergency pet care quantity demanded decreases from 1,000 to 950. That's a decrease in quantity demanded of only 5%. So we would say that this good, pet care, is not very sensitive to the price increase. I would say not responsive to this price increase, relatively. Whereas on the right, here's an example of if this good goes up in price from $5 to $6, let's say it's the cost of a sandwich at Jimmy John's. That's another increase of 20% in price. But our corresponding quantity demand decrease from 100 to 60 is a 40% decrease in quantity demanded. And we would say that's because there were so many other substitutes, sandwiches out there, that the increase in price drove a lot of people to the other store. We would say that this good is very responsive to a price change. The demand is very responsive to a price change. So that's a good kind of start off look at a couple of the kind of extreme examples of the elasticity concept, goods that are very not responsive or responsive to price changes. And that's really what elasticity is all about. Elasticity is the responsiveness to changes in price. There's several types of elasticity that we'll talk about. This is basically what the concept comes down to. And it's measured as a ratio of the change in the quantity demanded over the change in price in percentage terms. On the top here, we could get the number that represents the elasticity for pet care by saying this 5% decrease in quantity demanded in the numerator over the percent change in price, which is a 20% increase in price. And that gives us negative 0.25. We would say that's the measurement of the elasticity of demand, or ED, for emergency pet care. And in most cases, as your book talks about, the convention is to drop the sign. And so basically just take kind of the absolute value of this, and we'll get rid of the negative. We'll just say, because we assume, since the law of demand is that you have an inverse relationship between price and quantity demanded, that 0.25 is a negative when you're talking about demand. So you can basically ignore the sign when we're talking about elasticity of demand. All right, let's do this one on the right. Find the elasticity of demand for Jimmy John's subs given this data. We've got a 40% decrease in quantity demanded over a 20% increase in price. Again, absolute value gives us, let's say 2.0. Usually there's goes to the tenths at least when you're given these measurements. So it's an elasticity of demand of 2.0. We have characterizations or definitions, labels on these numbers that go like this. If the elasticity measurement is greater than 1, like it is in this case over here, it's very responsive to price. We call that elastic demand. Goods that have many substitutes tend to have elastic demand. People switch away from them and to other goods when the price goes up. Goods like emergency pet care that are not very responsive to price, people are going to buy them almost no matter what, or at least many people will. That's very not responsive. And the way the math works, since you've got basically a numerator and a denominator here, it's a ratio. It's going to be greater than 1 if the quantity demanded changes more than the price. That's elastic demand. Quantity demanded changes more than the price. And it's inelastic demand if the quantity changes by less than the price. Again, the quantity is not responsive to price changes. And then there's the special case where if it's exactly 1, if you had a 20% increase in price leading to a 20% decrease in quantity demanded, that would be called unit elastic demand. And it's right in the middle of responsive and not responsive. It's kind of, not too hot, not too cold. I wouldn't say it's just right. I mean, there's nothing right about it. It just happens to be right in the middle. That's a unit elastic demand. Okay, so that's our basic measurement of the elasticity of demand. The way that we'll most often measure it is actually slightly more complicated. We're going to use something called the midpoint method. And the reason we're going to use this is because percentage changes will vary depending on whether you're talking about increasing the price or decreasing the price. So let's go back up to this example up here on the right. And let me show you what I mean. We already said that with an increase in price of 20%, that leads to a decrease in quantity demanded of 40%. But what if we tried this going the other direction? What if we went from a decrease of price from $6 to $5? Well, decrease from $6 to $5 is no longer a 20% decrease. That's a decrease in price of 16.7%. And if we're increasing quantity demanded from 60 to 100, that's an increase in quantity demanded of 66.7%. Just because of the way percentage changes work, they're going to give you different amounts if you go in opposite directions. So what's most useful to say typically in elasticity of demand is what's the elasticity of demand within this price range? Kind of what's the average elasticity of demand in a range of prices from $5 to $6, no matter which direction you go. And that's what the midpoint method gives us. So this whole formula here, this being the numerator and this being the denominator, is our formula for the midpoint method. It looks pretty complicated. It's not actually as difficult as it seems once you get some practice with it. So here's how it works. You take, in the numerator, you're still trying to find basically a percent change in quantity demanded. You're just doing it in a different way. You're saying, okay, the change in quantity demanded, we'll use again this example from Jimmy John's. The change is the difference between 100 and 60. So that's 40. Units are not important. Over 1/2 of quantity demanded 1 plus quantity demanded 2, which is basically the midpoint. It's the average of these two. So the average of 160 is 80. You can get that by just eyeballing it, or if it's a little more complicated, add up 100 plus 60 divided by 2. That'll give you 80. And that's what goes in your numerator. In the denominator, we've got the percent change in price, which we find by taking the change in price, which is $1. You don't need to match up units here. It's not significant because we're just finding percentage movements. And then halfway between $5 and $6 is $5.50. If we simplify this, move the $5.50 on top. $5.50 times 40 is $2.20 over 80 on bottom. And that's going to give us 2.75. And that's going to be our elasticity of demand measured using the midpoint method for this data over here, that example on the right. Okay, so you're going to have a lot of practice problems. The first time through, this all seems kind of arcane, but the more you do it, the more you'll get comfortable with the method, and it's not too hard once you get going with it. Okay, next we're going to start talking a little bit about some of the usefulness of this concept when you're talking about the point of view of a producer or somebody who is, say, the store manager. Let's go back to the Jimmy John's manager again to talk about this. We want to find out a relationship between the elasticity of demand for a good and how that affects the revenue received by a producer. The revenue is the same as basically the money they're taking in. It's the price of the good times the quantity sold. And again, if you're the Jimmy John's manager, it's going to be important to you to know if I'm raising my price from $5 to $6, then how much is my quantity demanded falling? We said it was from 100 to 60. And what effect is that going to have on the total revenue I receive from selling this good? So let's just do these numbers and see real quick. We've got the total revenue 1 at $5 and 100 units is $500. Total revenue 2 at $6 and 60 units is $360. So assuming that cost per unit is about the same to produce for the Jimmy John's manager, it would probably not be a good idea, we would conclude from this, for him or her to increase the price from $5 to $6 because we would see a loss in total revenue. You'd get, a little bit more out of each unit you sell, but there's so many less people buying them that you end up making less revenue overall. And we can make some generalizations about the relationship between the elasticity of demand for a good and the total revenue, the change in total revenue that comes from a change in the price of the good. So notice what we had here was we have an elastic demand for a good. And when we increased the price, we decreased the total revenue received by the producer. And that is a general rule that actually just matches what's written right here. And this is just as a result of the math that's going on here. A good way to visualize this is if we put this on a graph, the graph here, you can do this without even putting the supply curve on here, just the demand for the good. From point A to point B, we can show the total revenue on this graph. If total revenue is P times Q, then the total revenue can be shown by this area here. The area of this rectangle is going to be equal to the total revenue received by this producer, by the Jimmy John's store, if the price is $5 and they're selling 100 units. If they raise the price to $6, here's the total revenue. P2 times Q2. We can show that by increasing the price, we're doing two different things. We're increasing the revenue received per unit. We're going to call that the price effect of the price increase. That's the price effect on total revenue here. But we're also decreasing the number of units we sell. And we can call that portion in there the quantity effect. When you're increasing the price effect is positive. It's increasing your total revenue. The quantity effect is negative. It's pulling your total revenue down. By the way, that quantity effect label really just applies to this rectangle right here. That is the quantity effect. It's an effect on total revenue. It subtracts from your total revenue when you raise the price. The price effect increases your total revenue when you raise the price. From this, we can kind of eyeball that the quantity effect is larger than the price effect, which it should be given that we have elastic demand. That means that we're subtracting from total revenue more than we're adding to it. You get the opposite effect if you have inelastic demand. With inelastic demand, let's go back to our example at the top. P1 was 5,000 and Q1 was 1,000. So the total revenue 1 was $5 million. Total revenue 2, 6,000 times 950. That gives us total revenue of 5,700,000. So with inelastic demand, if you increase the price, people are still going to buy it at they're not going to decrease their buying as much as the price is increasing. So an increase in price leads to an increase in total revenue. Again, that just matches the rule that's written right here. And then note in the case where demand is unit elastic, then the price and quantity effects will be equal and there will be no change in total revenue. One more visual way of seeing this that I think is helpful. A very steep demand curve can be used to illustrate pretty inelastic demand. Think of it this way. Here's a very small change in quantity as a result of a larger change in price. So a steep demand curve shows generally inelastic demand. We'll see it's a little bit more complicated than that in the next lesson. But since that's the case, what we're getting here, a positive price effect that's very large, and the negative quantity effect being pretty small. Whereas with very elastic demand, if you show a pretty flat demand curve, it's fairly elastic. A small change in price will lead to a large decrease in quantity. So we've got a fairly small price effect, fairly large quantity effect. So that can help too, thinking of inelastic demand curves as very steep and kind of drawing it out that way. If you forget these rules, if you have trouble just kind of memorizing them or easily mixed up, sketching out these curves and then reminding yourself that way I think can be helpful. Okay, we're going to stop there. We've got more to do with elasticity, but we'll work with this in class next time. See you then.